All right, so today what we're still doing like just another scenario. So it's still compound interest investments, and we've actually sort of looked at this in some of the exam questions before and the amortization tables. So we're sort of covered anyway. So it's when we have an investment with regular additions to the principal. So that means like you've got your investment which you give to the bank, and your payments are also going to the bank, and it's so that we get a bigger total. So we're trying to get an overall bigger amount at the end. All right, so examples of this can be the superannuation or investments. A lot of people, when they're getting close to the end of their retirement, so they'll put a big lump sum into an investment. They're going to keep on paying regular because they want a big chunk when they retire, and then they'll start taking it out. All right, so when you have a recurrence model for that situation, we can see that this big R is the interest added, okay? And this D, and it says plus D, and this is the extra payments. So this is the extra payments being added. Okay, so here when it says we've constructed a recurrence model, the only thing that's missing in there, and we should write, is we don't have the VO in there, which should be the principal written over here.
Is that just an accident or something?
Yeah, I'd say so. Over here it listed it here. Okay, so we've got an example here that we can explain. So Nor plans to travel overseas when she finishes her VCE. She has already saved $1,200 and thinks she can save an additional $50 each month, and she plans to add it to her savings. The account pays interest of 4.8% compounding monthly. Model this investment using a recurrence relation. So what we now have to do is first get that R value. So find out the R value, which we can see in our formulas, should be R over PPY over 100. Oh, sorry, it should be 1 plus. Beg your pardon. So it should be R equals 1 plus R over PPY over 100. So in this example, it'd be 1 plus, and they say 4.8 compounding monthly. So that's over 12. Monthly means PPY of 12 over 100. So we'll get our R value. Okay, so we get 1.004. So that's the recurrence relation. That's the big R. And so now if we're going to write the answer out, we'll put VO, which is her initial amount, which was 1,200. And then we're going to do VN plus 1. So that's where we write the R value, which is 1.004. Times VN, so you can, that should say VN over there too, that's a mistake. VN, and then you've got to add the payment. So D's the payment, so up here they told me she's going to add another $50, so that's 50. So there's a recurrence relation set up. So actually over here was a few little miss-ups, but on your summary sheet here, it's all good. Okay, so let's look at this one. So, we just did this.
Yeah, it's the same one.
Sorry, this one. All right, so here again, it's starting. She wants to travel overseas and 50 each month extra, but this one the only change is the 3% per month. So if we were working out the R, it'd be 1 plus 3 over 12 over 100. So that is, okay, so we get 1.0025 for that one. So if we were writing out the recurrence relation, she still started with 1,200 this time, and the VN plus 1 would be the R value times VN, and then we're going to add her monthly payments, which is still 50. So add 50. Okay, Nor's investment can be modelled using this. So this is set up there. Now it says use your calculator to determine recursively the value of Nor's investment has 3 additional payments. So after 3 goes. So I know it says use your calculator, but in your SAC, you're going to be asked, and in the exam, they're going to ask you to show it recursively. So let's do that here, and I'll show you how you've got to do it. So when we have to write it, we have to say VO equals, and we'll write 12,000. We have to write that V1 equals 1.0025 times the 12,000 plus the 50, and we'll get an answer. So we have to write that. So let's just, all right, so we did that one, and you get 1253. So then you've got to show that V2 would have been timesing that one, 1253 plus the 50, and you get your answer. So remember, we would probably round to 2 decimal places, and oops, sorry. So the next one you got to times it by the one before, plus 50, and you get your final, that one, which is 1359.40. Okay, so I know they just ask you to use your calculator, so you can, but in the SAC and in the exams, they'll ask you to show it, which means you've got to show those steps. In the exam, they often just have like, they might have a bit missing, so they'll have a box and they'll have some answers, but in the exam, you definitely have to, in the SAC, you have to show it, I would say. All right, so the whole thing. So B, what will the investment be after 1 year? So you could just keep clicking for, this was monthly, wasn't it? You could do 12 times, but it's starting to get annoying. So this is where we might start using Finance Solver, because we want to go great ahead. So what we can do is the investment, let's use Finance Solver. So we would want 12 payments, because it's 1 year. The interest rate, we're going to use, because we knew the scenario before. The interest rate was 3. The PV, she invested in the bank, so it was 12,000. She also made additional payments of $50, so that's negative as well, because you're giving into the bank. FV is your question, and PPY is 12. So let's go do that. Okay, so you end up with 1844.81. Okay, if you had have kept going recursively on your calculator, you would have found that V12 was also 1844.81. Okay. Okay, so we can have amortization tables, and we actually already did one of these in our examples in our other ones. So instead of, they're calling it principal increase, where we saw it in our other example, that was called principal addition. Same thing. So we have done an example of this. So we said where it was an investment, an annuity, but instead of taking it out, they were adding extra. So that was when we saw this scenario, which is what this is. This is an annuity where you're, instead of taking the payment out to use it, you're adding extra in to make it build. So you can see them, it's this same scenario of before. So she's adding the $50 and she gets the interest every month. So you can see that. And you can see here, we got up to the 12 and there's the total that we came up with. All right, so we've gone through this, so I'm going to leave it there. You've got it in your notes how you find all the little bits, but we have gone through one of these. So moving on to this one, it says La invests 500,000. So this will be your PV and it'll be negative because it's an investment at 5.5% per annum. So that's my I. Compounding monthly, so PPY is 12. He makes regular deposit, so that means he's adding into the bank, so it's a positive payment per month. What is the value of the investment after 5 years? So they told me that N would be 5 times 12 because it's monthly. So you can see we've popped that into Finance Solver and they said what's the value? So FV is the question. So you can see when we wrote them all out here, I've put FV is the question. And we type in everything. Just make sure when you're putting into the bank the payment, it's got to be negative. Press. Okay, so I wrote positive up here. When you're putting it into the bank in Finance Solver, it's a negative payment in Finance Solver, but you're actually adding to your investment, yeah? But adding to investment, I'll write that. Okay, and the final value after 5 years, here we get 692,292, and we'd round that up to 0.30. So you can see I've rounded to 2. All right, Mariska plans to retire from work 10 years from now. Her retirement goal is to have a balance of 600,000 in an annuity investment at that time. The present value of her annuity investment is 265, blah, 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 on which she earns an interest rate of 3.24% per annum, compounding monthly. To make the investment grow faster, Mariska will add 1,000 payment to the end at the end of every month. 2 years from now, she expects the interest rate of this investment to fall to 3.2% per annum, compounding monthly. It is expected to remain at this rate until she retires. When the interest rate drops, she must increase her monthly payment if she is to reach her retirement goal. So the value of her new monthly payment will be closest to. So you have a couple of things now. So can you see in there was a change in scenario, okay? So what you want to do is you want to get up to that first scenario, like at the end of the 2 years. So if you have a look, if we were to go and do that, so I'm going to write here, I'm going to think about it. All right, I'm going to find the final value at the end of those, was it 2? It was 2 years before it increased, was it? Yeah, 2 years. So the end of 2 years. So if I was going to do that in Finance Solver, off I'd go, I'd try to write. So it'd be 2 times 12, interest rate was 3.24 at that time. PV, so what she has at the moment. So she's investing in what she has at the moment, which was that, okay, up here. And then she was making, to make this investment grow, she will add 1,000 every month. So she was adding 1,000, okay, and we want to know what that final value was at that time, and PPY, it was monthly, compounding monthly. So this is where I found the PPY was 12, and I popped that in. So let's go find what the final value is. So at the 2 year mark, when the interest rate's going to change, we're going to see what it is. Okay, so we find out that she has 307,794 and that would all round up to 50. Okay, so we're at the end of 2 years, and now she needs to, the interest rate's going to change, and they're saying she wants to retire for 10 years now. So we're going to go for the next, this will be the next 8 years. And they're saying the payment is the question. So this is what we should have. So if you quickly wrote out all your things here. And then, so things that haven't changed. So we know that this is 12. Now, it will be 8 years from now. So we can say 8 times 12. The interest rate, we know it changed there. So we're going to write 3.2. That's why we're doing the change. And now the PV, we're pretending like we're starting again for this next 8 years. So this what final value that we've got is going to be my new PV. So I've put that in, negative 307,794.50. Now payment's the question, so that should be the only one blank. So that means we need to know what the final value is, because the payment's the question. And what does she want to retire on, the amount? What is it? Yeah, good. Up here it was, she wanted to retire on that 600,000. So we know that this has to be a positive 600,000. So we pop that in and we should get the answer for the new payment. Okay, so when I did that, I get negative 1854.05. So that would be what she has to pay in if she wants to retire with 600,000. So you can see that is answer E. Just maybe in your notes, you might want to pop up a big asterisk up here and just note that this is a change in scenario example, so that you know, you go, all right, that was one that we had where something changes. So if you're reading a new question and there's a change in scenario, you can quickly have a look at this and realise, all right, this may give you some hints on what you've got to do.